All right, let's get right into it. Today, we're putting on our developer hats and taking a hard look at the Palantir Ontology. We're going to strip away the marketing fluff and really dig into how this thing works under the hood, not just as a product, but as a genuine operating system for an entire company, and how it could completely change the way we think about building apps. So think about the code you write every day. How much of your time is spent just translating raw data, rows and columns from a database, into concepts your application can actually use? It's a ton of work. But what if the backend itself already got it? What if it already understood what a customer is or a product, not just as a row in a table, but as a living, breathing entity with relationships and actions tied to it? And that question right there is the huge paradigm shift we're talking about today. On the one hand, you've got the stack we all know. These passive data warehouses. They're just big, dumb boxes of information. All the important business logic is scattered across a dozen different applications, creating this massive, frustrating gap between your data and what you can actually do with it. The ontology flips that script. It proposes a dynamic digital twin of your whole organization, where the meaning of your data and the rules for acting on it are all unified in one single place. So here's how we're going to break it all down. First, we'll talk about why we even need to move beyond the traditional database model. Then, we'll get into the core idea, modeling the world in nouns and verbs. After that, we'll dive into the system architecture, the language, engine, and toolchain. We'll look at how it's engineered for serious scale, how you, as a developer, would actually build with it, and finally, why this whole setup creates an incredibly powerful, AI-ready backend. Okay, first up, moving beyond the database. The entire idea here is to stop treating data like something you just store away and instead make it an active, intelligent part of your day-to-day operations. As a full-stack developer, you live this problem every single day. You've got your data lake or your warehouse sitting over here, and your applications are way over there. And sure, the warehouse is great for running analytics, but it has zero clue about your business logic. All the rules, the permissions, the what happens when a user clicks this button, that's all locked away in your application code, often repeated in multiple places, which just leads to a brittle, fragmented mess. So how does the ontology even begin to fix this? Well, it introduces this really powerful abstraction, modeling the world in what it calls semantic and kinetic layers. Honestly, the best way to think about it is like object-oriented programming, but for your entire business. So on one side, you've got the semantic layer. These are your nouns. This is where you define all the things that matter to your business. A flight, an aircraft, a supplier. It takes all your raw, messy data from a bunch of different sources and maps it into a clean, connected model of these real-world objects. And on the other side, you have the kinetic layer. These are your verbs. This is where you define the actions that you can take on those nouns. It encodes all your business logic, all your governance rules, things like approve purchase order or reroute shipment. Now, for us developers, this slide is the real aha moment because it translates these fancy-sounding concepts into the language we already speak. An object type in the ontology? That's basically a table or a dataset. A property? That's just a column. A link type? It's a predefined join. And an object instance? Well, that's just a row. So you see, this isn't about reinventing the wheel. It's about putting a really smart semantic layer on top of the data structures we already use every single day. All right, let's peel back another layer and look at the system architecture itself. Because under the hood, the ontology isn't some single monolithic thing. It's a pretty sophisticated system with very distinct architectural layers. It really breaks down into three key parts. First, there's the language. This is the modeling framework you use to actually define all those nouns and verbs we just talked about. Second, there's the engine, and this is the real workhorse, the heavy machinery that runs everything, handling massive queries, transactions, and real-time updates at scale. And third, there's the toolchain, and this is where you come in. This is the developer-facing layer with all the goodies like the Ontology SDK and other DevOps tools. And it's worth taking a closer look at that engine because it's pretty cleverly designed. It actually has a dual architecture. The read path is optimized for exactly what you'd expect. Super fast, high concurrency queries, and searching across millions or even billions of linked objects. But the write path is built for something totally different: scalable, atomic, and durable transactional updates. This ensures that every single change is consistent and fully auditable. Okay, now let's get into the part that every engineer loves to talk about, the nitty-gritty. How is this thing actually built to scale? And to do that, we have to look at the evolution of its storage backend. Like any huge software system, the ontology didn't just appear overnight. it's evolved. The original backend, which was called Object Storage v1 or Phonograph, it was great for its time, but it eventually just hit a wall. It started to struggle with the absolutely massive data sets and the incredibly complex many-to-many relationships that you find in any real-world enterprise. And this table right here just perfectly shows the massive performance gains in the modern backend Object Storage v2. I mean, just look at these numbers. The max edit size jumped from a tiny 32 kilobytes to 3 megabytes. That's a 100x increase. Indexing throughput is way faster. And the really critical one, complex search-around queries on objects with, say, 700 million rows. OS v1 could really lag, but OS v2 is highly optimized for it. This isn't just a minor update. This is the kind of serious re-architecture you need to do to support true enterprise scale. So what's powering all this performance? It's a data ingestion process they call the funnel indexing pipeline. Basically, it reads from all your source data sets, chews through them in a parallelized Spark backend, transforms all that raw data into the proper ontology format, and then pushes those updates into specialized object databases, all primed and ready for those high-speed queries. Okay, so we've covered the why and the how, but what does all of this actually mean for you, the developer on the front lines? How do you actually build something with this? Well, you get a whole suite of tools to work with. Your main entry point is going to be the Ontology SDK, or OSDK, which lets you build your custom apps using the ontology as your backend. You can easily integrate it with platforms you're probably already using, like Snowflake, or use webhooks to trigger actions in external systems. There are even tools like HyperAuto to bootstrap your whole ontology from sources like SAP, which is pretty cool. And of course, you can define fine-grained, row-level security right from the get-go. Let's just zero in on the OSDK for a second, because this is probably the most important piece for any developer. This is the toolkit that lets your code speak the ontology's language. So instead of writing a bunch of SQL queries and boilerplate data access code, you're interacting directly with high-level objects. You're reading properties, you're traversing links between objects, and you're executing those governed, predefined actions we talked about, all from your own application. And finally, let's tie all of this into the single biggest trend in technology right now. This entire architecture, the semantic layer, the kinetic layer, it all comes together to create a uniquely powerful and, most importantly, a governed backend for AI. So, one of the immediate wins you get is true semantic search. Because the ontology is structured, it can automatically create vector embeddings for your data. What that means is an AI can find information based on its conceptual meaning, not just simple keyword matches. So a search for protective equipment could find documents that only mention hard hats, because the system actually understands that those two things are semantically related. And that leads to the real game changer here, something called Ontology Augmented Generation, or OAG. This is the technique you use to ground a large language model in your business's reality. So instead of just letting an LLM make stuff up, you feed it real-time context from your ontology, the objects, the links, the available actions. This is how you make sure an AI's responses are accurate, relevant, and actually actionable within your company's rules. And that's really the crucial takeaway here. The ontology becomes this foundational layer, this governed semantic substrate for your AI systems. It's the thing that transforms a large language model from being just a clever but kind of unreliable text generator into a true operational partner that understands your business rules, respects your security, and can safely take actions in the real world. And that really brings us to the final thought I want to leave you with. As developers, we're so used to building all that business context into our application layer ourselves. But just take a second and think about it. How would you architect your next application, your next microservice, if you could just assume the backend already knew the nouns, the verbs, and all the fundamental rules of your business? It's a pretty powerful question to think about.